This is my final project presentation for CS 4620 Database Systems at Ohio University. For my project, I took two sets of data of Mars' surface, one of elevation data and one of imagery data, and I compiled it into a database of 1 degree by 1 degree tiles with which any multitude of programs could be written, but in my case, I wrote a program that visualizes the surface of Mars in 3D space, allowing the user to traverse the surface, move the camera around, and tiles are loaded in and out on demand, allowing the user to travel across the entire surface and visualize the data without actually having to have the full data sets loaded on their computer, because the full data sets add up to about 23, 24 gigs of data, which is a tremendous amount. But if the user is querying only for the data that they need, they can use obviously as little as they need. So I'm going to start with a demo of the actual final product, and then I'll get into how some of the database related things work. When you first start the program, you're dropped into this scene. And what you have here is a specific position on Mars' surface that I picked. I picked it kind of arbitrarily. I just picked a surface that looked cool. It's not of any significance. And as you can see, we have a 3D model of Mars' surface. And it's also textured from the imagery data. And if we go further away from the origin, you can see that you can actually see the edge of the tiles. But if you go far enough, new tiles load in as they're needed. And you can keep doing this for as long as you would like, and they will keep loading because this is the entire planet of Mars. The entire planet of Mars is covered in this database. So you could travel the entire planet, although I feel like that would be a bit boring, so let's move on to the code portion. So the code for this project is broken into 3 different programs. The first program actually builds the database from the 2 datasets. This is written in Rust, in the Rust programming language, and it uses the Diesel library for interacting with MySQL database backend. And it uses GDAL to actually load the datasets and process them. So the code here itself is not super important. This is mostly just me scaling the datasets and ensuring that the tiles are seamless. But what's relevant is these few lines right here. This is actually what performs the database queries. And I've written here in this comment the SQL query analog of these 4 lines right here. So in Diesel, you don't actually write SQL queries as strings yourself like you would in, say, C++ or C. In this case, it's actually a bit cleaner and a bit more secure. So what we're doing here is we're inserting into the tiles table. And the values that we're inserting are this vector of tiles I've called batch, because I actually batch a few tiles to insert them all at once instead of doing tile by tile. And I execute that on the MySQL connection, and I expect that the result is a success and not an error. So Diesel actually handles the conversion to a SQL query itself. So it's more secure because it handles any encoding of user input, doesn't expose any vulnerabilities like a programmer could if they didn't know what they were doing. And it's just overall very nice and easy to use. The second program actually is an HTTP server that takes HTTP requests for elevation or imagery data. It actually queries the database to get that data out, and then it returns that data as the response body of the HTTP request. So the relevant parts for this are these 2 functions right here, elevation requests and imagery request. Elevation request handles requests that are made for elevation data. So the line that actually queries the database is this one. In the tiles table, select out the tile ID and the tile elevation data, and give me only the ones where the ID equals the given ID from the HTTP request. And then this is the SQL analog of this Diesel query. So we're selecting the ID and the elevation data from tiles where ID equals question mark, where question mark here means the ID given in the request. And then we're checking to see if that query executes correctly, and checking to make sure that the response of that query is not empty. And then we return the data if so, otherwise we return an error 404 not found. And then the same thing for the imagery data, except instead of getting the elevation data, we're getting the imagery data out. So that program was very straightforward. And then the visualization program is even more straightforward because it doesn't actually make any interaction with the database itself. It just goes through the HTTP server, so it just makes HTTP GET requests for elevation or imagery data and uses the resultant data to actually render to the screen. So the last thing I want to show is actually some of the queries being made in real time. As part of the server, I can pass one command line argument to debug the queries. And what this does is whenever it makes any database queries, it prints the actual SQL string out to the console. So what we're going to do is run that with that option, and we're going to run the visualization program. And if we go back to the console, we see that it's being filled with these requests. So this offers a way for me to sanity check my queries and make sure that they are correct, and I have verified that they are correct. And if we move in the world from the origin and force more tiles to load, you can see that more queries show up in the console. So this is a way of showing in real time what queries are being made. And it just works as it is expected to. And you could travel, of course, across the whole entire surface of Mars, but obviously we don't have time to do such a thing. So I will end the video here.